Okay, for example, if we got a question where a stress is applied on a solid cylinder during compression testing, the applied stress resulted in a 3D strain where epsilon x is strain in x direction, epsilon y strain in y, epsilon z strain in z direction. That symbol is known as epsilon. Resulting strain is modeled, modeled by the following equation. So this is the equation they are modeled by. So 3 strain x plus 2 epsilon y plus 1 epsilon z equals 7. The other one is 1 epsilon x minus 2 epsilon y minus 1 epsilon z is 1. Then the third equation is 1 epsilon x plus, that's not given, so I just put 0 here because, yeah, but still you need to write 0. Plus 3 epsilon z is 11. Make sure when you do that one, x's, the y's, the z, they should be in order. And so that's it's modeled by this equation. Using inverse matrix method, calculate the value of the strain in 3D. So now we need to find the value of the strain in 3D. To do that one, we need to convert that into the matrix method. So let's go in the next page and let's convert that into the matrix. When we go back and we convert that into matrix method or matrix notation, it becomes a 3, 1, 1. Let me just write it properly. 3, 1, 1, 2 minus 2, 0, because that was a 0. 1 minus 1, 3. And on this side, because we have to write down proper order, strain x, strain y, and strain z in a specific order. And that thing is equal to 7, 1, 11. Now you will name it. I will call this one as A. I will call this one as X. And I will call this one as B. AX equals B. So this, now I need to move the A on the other side. So X equals A inverse B. I know what B is. I need to find the X, but I don't have a clue about A inverse. So now we need to find the A inverse. That will be my step 2. Step 1, convert into that form. Now you need to find the A inverse. A inverse also has a formula. Now step 2, we find the A inverse. And we have a formula for A inverse. A inverse, I'm just going to write the formula here. A inverse is 1 over A determinant. And we said adjoint or adjugate of A. Yeah. Now you need to use the matrix A to find the determinant of that one. So I'm going to call that one now step 2A. So step 2A is find the A determinant. You have the matrix A. The matrix A was 3, 1, 1, 2 minus 2, 0, 1 minus 1, 3. Okay, now when we want to find the A determinant, we write down 3. Yeah, so this 3 is going to be here and 2 lines. This 2 will be minus 2. Yeah, and then 2 lines. Why minus 2? We change the sign. And then plus 1 and then 2 lines. Yeah. Now in the first one, this 3, I'm not going to count that one, but I'm just going to look at the rest one. Minus 2 minus 1, 0, 3. Minus 2 minus 1, 0, 3. For the 2, I'm not going to count that one. Remember the Super Mario thing? 1, 1 minus 1, 3. And then this one, 1 minus 2, 1, 0. and then we just solve that one. The 3 is already there, bracket. 2 minus 3 minus 2 is minus 6, and then minus 0, because that time this is 0. 1 times, and then the minus 2 comes here, so the minus 2 is there. 3 times 1 is 3, minus 1 times minus 1 is minus 1, so another minus 1. These two minus 1 will make a plus 1. 0 times 1 is 0, minus 1 times minus 2 is another minus 2. So that will become a plus. Let's do that one. That is 3 times minus 6, minus 2 times 3, plus 1 times 2. So that 3 plus 1 should not be 3. It's 3 plus 1 is 4. Yep, so that's a 4. And then 2 times 4 is also 8, not 6. So the A determinant is minus 24, which means it's a non-singular matrix, which means you can solve further. Yep. So usually it's better idea to write down it's a non-singular. So the solution does exist. Now we got the matrix, which is given by, let's get rid of that one. I just copy this one from there. So we got the matrix. Now that I need to find out, the next step I need to do is I need to find out the adjoint of A or adjugate of A. To do that one, I need to do for each and every element. So I need to find out the minor matrix. So I need to find out the minor matrix. So if you go back, look at my previous slides, previous videos, it will show you how to find the minor elements for all these ones. So now the next step is find minors. Find minor for element. When you find the minors, this will be the minors. Yeah, you can have a look at previous video how to find the minors. Okay, the next step after the minor is you find the matrix of cofactor. The cofactor is you just use the diamond, you just change the sign. So that will be AC, but that will be minus 6, minus 4, 2. Actually, let me write the matrix first and then I change the sign. 6, 8, minus 2, 0, minus 4, minus 8. Then you just change the sign of these ones. So I already changed the sign of that one to negative. That will be a negative. That will become a positive, and that will become a positive. Next step is you just transpose this one. So that will be minus 6, minus 4, and 2, minus 6, 8, and 2, 0, positive 4, and negative 8. And this matrix, after transposing, we call that one as adjugate of A. Once we got that bit, what we need to do is we got the A determinant and all that. We will put in this equation to find the inverse. And we have this matrix as well. So that matrix was minus 6, minus 4, 2, minus 6, 8, 2, 0, 4, 8. Yeah. So if you want, you can divide everything by 24. When you divide everything by 24, you will get an answer for the A inverse as the A inverse will be 3 over 12, which you can simplify. So minus 6 over that, you can simplify. All of them you can simplify, and you will get an answer A for A inverse. This is negative 8, not 8. So what you do is you do minus 6 over minus 24, minus 6 over minus 24, 0 over 24, minus 4 over minus 24, 8 over 24, 4 over 24, 2 over 24, I mean minus 24, this is minus 24, not 24. That's minus 24 as well. 2 over minus 24, minus 8 over minus 24. They're all minus 24. Yeah. And that will give you an answer for the A inverse in a simplified form. It's better to simplify because it will help you for the later calculation. So we will get the value of the A inverse. When we get the value of the A inverse, simplified version, you need to put it back into the other equation. Okay, so we got A inverse. A inverse, we put it back in this equation. A inverse B. A inverse is that, and the B is this matrix. Now we put the values and we find out, we multiply them actually. So now you know how to multiply. When we multiply this times that, but before that we can check if we are able to multiply. There's a 3 cross 3 and there's a 3 cross 1. So yeah, if they are same, column of the first, row of the second, the same, we can multiply, and the resultant will be 3 cross 1 matrix. So when you multiply, you will get an answer something like that. Yeah, so this times that plus this times that plus this times that will give you an answer, and then you do this times that plus this times that, sorry, this times that plus this times that, that will give you another answer. And let me write it down. And then we do this times that plus this times that plus this times that, and another answer. And this was your values for the strain. So strain in X is 2 micro, let's say it's micro strain, if that's in micro strain. Strain in Y is -1, and strain in Z is 3. The -1 shows that it has reduced in that direction. The X shows that it's a positive strain. It has elongated in that direction. Here I just put micro strain. It can be millimeter because in the question it wasn't specified, so it can be any value. Yep. You can go and check this one if you go and put it back into the equation, the real equation, which was here. If you put these values here, 2, -1, and 3, you will get an answer 7. Yep, this is just to check. So if I just do check that one, so 3 times 2 plus 2 times -1 plus 1 times 3, that should give me an answer 7. Yep, 6 minus 2 plus 3, that is 7. So that means that's right. Trying two equations, all equation will be same answer. Yeah, correct answer.